All right, you guys, today is day 17. We're nearing the end of another unit. We're looking at lesson 60, which means next time we meet, we will start going over the review. Have class time to do as much as we can, go over it, grade it the next day. Again, we like to slow down when it's review time just to make sure everything we've covered is all making sense in the review before we take the test. So today we're looking at, pretty simply, it's area of a parallelogram. So area of a parallelogram, it's on your reference sheet. We've talked about it many times in the past. It's just base times height. Now a square is another form of a parallelogram. So we say side squared or side times side. That could still be base times height. Rectangle, length times width. Well, the length and the width we could also call base and height. So we've worked with parallelograms, but it doesn't always have to have square corners. It's not always 90-degree angles, and it can still be a parallelogram. Okay, so base times height. Now that's our formula, and we will usually be given, I think actually always for the ones today, we'll be given the height. Usually it's a dashed line on the inside or the outside of a parallelogram, unless it's like a rectangle where one of the sides meets the base at a right angle, in which case that would be the height. And that's showing right here. Well, triangle is base times height divided by 2, or 1/2 base times height. That's because a triangle, if we were to draw a rectangle and cut it in half with the diagonal, we have two congruent triangles. So a triangle is really half of our parallelogram. So that's why it's 1/2 base times height. So we get that formula from. Okay, so if we're looking at this example, we have base, and then our height is right here, indicated with the dashed line. We know this is the height because it meets at a right angle. If we were finding the perimeter, which we were asked to do, we would do 8 plus 8 plus 6 plus 6, which is 28 centimeters. Parallelogram, just like any shape, you add up all the sides, that's your perimeter. Area is base times height, so we plug in 8 centimeters and 5, not 6. Don't do 8 times 6 because this is going up not at a right angle, so this is not our height. So the height right here can be drawn inside, or sometimes it'll be outside with the dashed line meeting at a right angle. Okay, that doesn't mean that's some sort of additional side or anything like that. It's just telling us that is the height, and it'll show us that right angle, so we know for sure that this is the height. So then we do 8 times 5, which is 40, and centimeter times centimeter is centimeters squared. Okay. If we're drawing on a coordinate plane, again, whether it's triangle, parallelogram, rectangle, whatever, we plot our points. These are our 4 points, A, B, C, D. Okay, those are our 4 points. We plot them in our coordinate plane, and then there's a dilation of 3. So we multiply 2 times 3, 1 times 3. There's a new point. 1, -1 by 3, -2 by 3, -1. And those become all of our new points right there. And then the area of the image is how many times that of the parallelogram. Well, we look at the original one here. We plotted our points. We have 1, 2, 3 for the base. The height, we can just count from the base to the top. 1, 2, that's where the graph paper and the coordinate plane make it a little bit easier. So 3 times 2 is 6 square units. Now we've dilated it by 3. So we go over 1, 2, 3, 4, 5, 6, 7, 8, 9, which makes sense. 3 times 3 is 9. And then we're up 1, 2, 3, 4, 5, 6. 2 times 3 is 6. So now we have 9 times 6, which is 54 square units. And then the area of the image is how many times the area of the parallelogram. So 54 divided by 6, that gives us 9. So if we dilate it by a scale factor of 3, since it's area and it's scale factor squared, which would be 9 times bigger, not 3 times bigger. A lot of times we get in a hurry. Oh, we use this with drafting and things. If we're drawing a scaled down version of a house or a building or plans in the yard or whatever, and we have a scale factor, we have to remember if it's area, we're looking at the scale factor squared. So 3 squared is 9. That's why the dilated parallelogram is 9 times that of the original. because this was multiplied by 3, the base was multiplied by 3, and so was the height. So 3 times the base times 3 times the height. 3 times 3 is 9. The perimeter would go up, would be 3 times greater, but the area would be 9 times greater. Okay. We'll look at the practice set together. So area of a parallelogram, base times height, base times height, base times height. Okay. We have the height here, as we were mentioning. So we'll go over this together in class.